So again, in 2a, we are solving a logarithmic equation, and part of solving logarithmic equations is combining as a single log. Now on the right-hand side, I could combine those logs, x plus 6 times x minus 1, because multiplying inside of a logarithm is same as adding two logarithms. Now at this point, there is a shortcut. So I'm going to show you the shortcut first, and then we'll do the long cut afterwards. Okay? The shortcut is using an idea that is just based on logic, saying that if I have log of something and it's equal to log of something, then those somethings have to be the same. And so I would get 6x is equal to x plus 6 times x plus 1. And now this is a quadratic equation. How do we solve a quadratic equation? We make one side equal to 0. I'm going to expand this, x squared plus 7x. Oh, it was a minus 1. Thank you. So this is x squared plus 5x minus 6, and then I would subtract 6x on that side as well, giving us 0 equals x squared minus x minus 6, which factors nicely, x minus 3, x plus 2. And so we get two solutions, x is equal to 3 and x is equal to negative 2. After solving an exponential equation, you always have to plug your answers back into the original equation to see if you're ever taking the log of a negative number. Now when I plug in positive 3, I have 6 times 3, that's 18, positive number, that's fine. X plus 6, 3 plus 6, 9, positive number, that's fine. 3 minus 1, 2, still a positive number, that's fine. So we can say that x equals 3 works. But when we plug in x equals negative 2, right away 6 times negative 2 is negative 12. Can't take the log of a negative number. We just have to find one place where we're taking a log of a negative number in order to say, no, that answer is not part of the solution. Now, the long way is following the steps that we had before, and the steps are always combine as a single logarithm first. Now, in this question, we currently have a problem because I went to the wrong screen. There we go. We currently have a log on one side and a log on the other side. In order to combine logs, they would need to be on the same side of the equation. So I'm going to make this side, the left side, 0. I still have log. I'm going to expand this, x squared. No, I'll just keep it x plus 6, x minus 1. We have that in the log already. If I subtract log 6x on both sides, I have a log law for a log minus a log. What's that log law? Division. So I can write this as log of, this would still be on top, and now there would be a 6x on the bottom.
If you were to expand it, would it like, and you got like x squared, 5x, like, and then you had that over 6x?
That's fine. The reason I didn't expand it is because once you, no, I wanted to point out that it's exactly the same as the shortcut, just longer. Makes sense? At this point, we have a single logarithm. Now we can use the definition. The definition of a log says, in this case, my base is 10. My exponent would be 0, and it would equal x plus 6, x minus 1, all over 6x. And if I wanted to get rid of that fraction, I could multiply both sides by 6x. What is 10 to the 0? 1. 1 times 6x would be 6x equals x plus 6, x minus 1. And the reason I didn't expand it is because I wanted you to see that it was exactly the same as where we went directly in our shortcut. And you would solve it from there the same way. get x equals 3 and x equals negative 2 and check them to find out that one works and one doesn't. And what is important for knowing about the shortcut is it only works when you have log of something equals log of something else. You can't have any extra numbers in there. It only works when it's log of something equals log of something else. So I've seen students try to use the shortcut when there's a -1 afterwards. It doesn't work. You have to use the long cut. I like that word, the long cut. So let's go to part B, which we didn't look at earlier this morning. 3 equals log 2 of x plus 2 plus log 2 of x. Combine it to be a single logarithm. Do we have a log law for adding? Yes. We multiply. And after multiplying, do we have a single log now? Yes, we do. Use your definition. In this case, the base is 2. The exponent is 3. It's equal to x plus 2 times x. What kind of equation is this? It's a quadratic equation. How do we solve quadratic equations? Make one side equal to 0. So I'm going to subtract 8 on both sides. Factor. So it becomes x plus 4, x minus 2. And we get x equals negative 4 and x equals 2. We need to check. If I plug in negative 4, do I ever have a negative number inside of a logarithm? Yes, I do. So that one's going to be bad. If I plug in 2, do I ever have a negative or 0 inside? No. So that one is good. Okay, questions for this one are 11 and 13. So I'm going to give you 15 minutes to work on this, and then we're going to do a Kahoot on logarithms. I've got candy. I got candy. 10 minutes so we can play more?
No, so that you don't have to leave.
Oh, these are good.
Are they the circle? Like the flat? Or like. Oh, yeah. There's a difference. Hey, is anyone going to Linwood?
No, that wasn't an option.
So dirty.
The mood was kind of bad, though.
Yeah.